functions. There are two limits that we need to consider before we get started here. The limit as x goes to 0 of sine x over x is 1. Yes, that's good. The limit as x approaches 0 of cosine x minus 1 over x is 0 as x approaches 0. So we're going to find the derivatives of all the trig functions. All right, so in order to do this, we need to prove what our derivatives are, and we're going to take the derivative using limits. So this is f prime of x equals the limit as h goes to 0 of sine of x plus h, good, minus sine of x all over h. The limit of, as h goes to 0 of, now may I plug in h here in this grand limit that we've got going on here? The answer is no, because I have a domain error here. So I have to do something algebraic.
Yeah.
That certainly looks like the sign of a sum. Oh, that's a trig identity.
Yeah, it is.
It is.
Sine x squared.
No, it's sine, cosine, cosine.
Plus.
Or is it sine, cosine, cosine, sine?
It's positive.
I think it's
definitely
sine. Sine of x, cosine of h,
Yeah.
plus, and the sign stayed the same. Sine, cosine, cosine. Sine, cosine, cosine, sine. Minus sine of x all over h. Now, I'm going to do some creative factoring. I'm going to take this term and I'm going to take this term and I'm going to factor a sine x out of it. The limit as h goes to 0 of sine x times what's left on top, cosine h minus 1 plus cosine x sine h. All right, and then at the same time, I'm going to bust up the fraction and say this is over h and this is over h. Is that legal? Anybody see anything?
Yeah, we got a 0 guy.
Okay, we do. We have one limit here that's equal to 0, and we have a 1. That's nice. So the 0 wipes out this whole first term, and then I'm left with cosine x. So the derivative of sine x is cosine x. So I have f of x equals sine x. Its derivative, I like to do a summary chart here so that when we do some practice at the end. This is f of x equals cosine x. Let's see what f prime is.
I have a question.
Yes, sir.
If we have this on like a test, we can just go right to it. We don't have to do
I have been known to ask you to prove using the definition of the derivative. So if you need to know sine, cosine, cosine, sine, the answer is yes. All right, let's do another one. The derivative of cosine is going to be the limit as h goes to 0 of cosine of x plus h minus cosine x all over h. I'm going to ask you, can we use substitution here? The answer is no, because I can't have a 0 in the denominator. So I'm going to have to use the cosine of the sum formula, which is now instead of sine, cosine, cosine, sine is cosine, cosine, sine, sine, and the sines collide. Yeah, they're opposite. Yeah. Okay, so this is cosine x, cosine h, minus sine x, sine h, all over h. Everybody agree?
Minus you forgot to write.
Oh, yeah, minus cosine x. Thank you very much. You're absolutely right. So what am I going to do? Some more creative factoring. And when I say creative, I'm just saying that I'm just going to reach across the equation. And I'm going to factor out a cosine. So this is cosine x, and what's left? Cosine h minus 1. Good. Minus sine x, sine h. And I'm going to bust up the fraction again like I did in the first problem. And what do we notice? Oh, I see a 0. Do you? The limit as h goes to 0. This one goes to 0. What about the sine h over h? Does everybody see that that goes to 1? Yes? And if I take h to 0, then what am I left with? Negative sine x. All right. So the derivative of cosine x equals negative sine x. And I'm on to tangent. Now tangent is undefined in a couple places. Do we remember where? I've got it up here. Pi over 2, so pi over 2 is plus pi n, and an element of the integer set. And what kind of slopes does it look like? And this is like a lime green, so I'm sorry if you can't see it, but what kind of slope does it look like tangent has? Always positive, right? Never negative. And always increasing. All right. So f prime of x is equal to the limit as h goes to 0 of tangent of x plus h minus tangent of x all over h. Anybody want to do that? Tangent of a sum.
Oh,
What did you say? Sine thing.
Sine x plus h.
The sine of x plus h over the cosine of x plus h. Everybody want to go that way?
No, but can we do the tan x minus tan h?
Yeah. Oh, right. Yeah, it would be. It actually would be tan of x plus tan of h over 1 minus tan x tan h. Yes, I'm so thrilled that you remember that. But wouldn't it be nice? What is tangent?
Sine over cosine.
Sine over cosine. Could we use the quotient rule?
Yeah.
Since we already know the derivatives of sine and cosine because we derived them. Would you prefer to do it that way?
Yes.
I would. Let's do it that way. So we'll save this for another day. So using the quotient rule. We would say f prime of x is O, which is O, which is cosine x. B high, which is the derivative of sine.
Cosine x.
Good. Cosine x. Minus high, which is good. Sine x. D ho, which is negative sine x. All over cosine squared x, because that's ho ho. All right, on top I get cosine squared x plus.
Oh my gosh, it's 1.
Oh my gosh, it's 1. Something wonderful just happened to this derivative. It's 1 over cosine squared x, which happens to be, that's right, secant squared x. So f prime of x is secant squared x. So let's talk about secant squared x. Do we remember what that graph looks like? We took the cosine graph and we took the y values and flipped them upside down, right? Reciprocated them. And so it was, for lack of a better word, used, up and down used. And what happens when you square those? They become all positive, don't they? And the secant graph is never 0. So does it look like this secant squared could give us all the y values? All the y values of secant squared could give us the slopes? The answer is yes. Okay, so we can say f prime of x is equal to secant squared x. On to cotangent. Do we remember the cotangent of a sum? No, so let's use the quotient rule, right, Hank?
Exactly.
All right, and what this is? Cosine x over sine x. So f prime of x is sine x. Good. D high. Negative sine x minus high, which is cosine x. D ho cosine x. All over ho ho, which is sine squared x. All right, so on top I'm getting negative sine squared x minus cosine squared x all over sine squared x.
How come the sine
Yes,
x-
background negative. What?
How come the sine x is negative and the cosine x is?
Okay, this was ho. We took the derivative of we copied the denominator, took the derivative of the numerator. The derivative of the cosine is
Oh, wow.
negative
Okay.
sine x, right?
Yes.
Factoring out a negative 1, which is a great idea. What does that do for us? Gives us a 1 on top. So this is negative 1 over sine squared x, which gives us negative cosecant squared x. When you square something, it's always a negative number, isn't it? If I have a negative in front. Does cotangent look like it has always negative slopes? The answer is yes. So something squared multiplied by a negative number is always negative. So that makes sense that these would all be negative, I hope. Secant. Now, I don't remember the secant of a sum, and I certainly don't want to do 1 over the cosine of a sum with limits. Do you? So what can we do? We could make this. No, make it tan. We can make it 1 over cosine. And use the quotient rule. Good. So f prime of x is going to be ho, which is cosine x, d high, which is, what's the derivative of 1? 0. Good. 0 minus high, which is 1, d ho, which is negative sine x, all over ho ho, which is cosine squared x. So this first term goes to 0, and then I get a sine x over now nobody ever leaves it this way. What they do is they bust this up into 1 over cosine x times sine x over cosine x, which is what? Well, this is secant x tan x, and yes, that is the derivative of secant. Now, it's a little bit different, but that's the truth there. So f of x is secant x. The derivative of secant again is secant x tan x. Now, what do you do when you go to the beach? You seek tans, don't you? Don't you? That's how I remember that. Seek tans. If you were a betting person, what do you suspect the derivative of cosecant might be? If you follow the pattern. What? Negative cosecant x, cotan x. Let's see if it's true. We're going to use 1 over sine x. So what is f prime of x here? O Sine x, d high, good, 0 minus high, which is 1, d ho, which is cosine x, good. All over sine squared x. Okay, so this goes to 0, and we're left with negative cosine x over sine squared x. Now, do we leave it like that? No, we say negative 1 over sine x times cosine x over sine x. And then we're going to get what? Negative cosecant x, as you guys predicted, cotan x. All right, so the function is cosecant x. The derivative is negative cosecant x, cotan x. And yes, I strongly recommend that you memorize these. Questions on that? Let's do a couple of practice problems. In your books,
One of the ones that's on the whole.
I'm going to do the evens. No, you get to do the odds. Okay? What is the homework for? For you guys to practice.
Are we practicing right now?
I am practicing and you're working them with me. So that doesn't mean you're working them on your own. Okay, so let's do number 2. If y equals 2 sine x minus tangent x, I need dy dx, okay? So remember, constants just go along for the ride, because if I use the product rule here first, or for this first term, I'd say first, which is 2, d second, which would be cosine, plus second, which would be sine, times the derivative of the first, which is 0. Do you see how the second part's always wiped out if you use the product rule with the constant? So this is going to be just 2 times the derivative of sine, which is cosine x, minus the derivative of tangent, which I have the summary up here on the board. So secant squared x. That was tough. We're done. 4. Y equals x secant x. What rule do I have to use here? The product rule, because I have 2 functions I'm multiplying together. Okay, so we're going to say dy dx equals first, which is x, d second. What's the derivative of secant x? Secant x tan x, plus second, which is secant x times the derivative of the first, which is 1. Right, because this is first d second plus second d first. And then this is just x secant x tan x plus secant x. Now, could you factor out a secant? Sure. And we get x tan x plus 1. And then if I asked you to find the slope at root 2 over 2, you guys could probably do that. I mean, or at pi over 4, you could tell me what the slope was, right? And come up with the equation of the tangent line. Those kind of problems don't ever go away. All right, number 6. Gosh, we're motoring right along. 3x plus x tan x. Sometimes in a problem, you have an easy part and then you have another part that maybe requires you to use a different rule. So you can have 2 rules in one derivative. Okay, so this is dy dx equals, what's the derivative of 3x? 3, good. And then I have to use what rule here? The product rule, because I have a first term and a second term and they're being multiplied together. So this is going to be plus first, which is x, d second, which is secant squared x, good, plus second, which is tan x, times the derivative of the first, which is 1. Good. And there's no simplifying that. I mean, we're stuck with that. I mean, we could change the secant squared x to 1 plus tan squared x, maybe. But I mean, if I just have to put an x value or an x value in to find the slope, I could do that with this. Okay? Number 8 is x over 1 plus cosine x. Well, what rule must I use here? The quotient rule, that's right. So ho is 1 plus cosine x, d high, which is 1, minus high, which is x, d ho, which is the derivative of 1 is 0. The derivative of cosine is negative sine x. Good. All over 1 plus cosine x, quantity squared. Now, I'm going to caution you right here because, boy, is it tempting.
Yes.
It's staring at you to want to cancel out that 1 plus cosine x and that 1 plus cosine x up squared on the bottom. Don't do it. Why can't we do it? Because I have something wrong. This has to be added first, doesn't it, in the numerator? You can only cancel factors. Are these factors? No. No. Resist. So we're simplifying. So this is 1 plus cosine x plus x sine x all over 1 plus cosine x quantity squared. And there's nothing you can do with that. We just leave it.
Minus. It's multiplication.
Yeah. Yeah. Okay. So and there's nothing you can do except plug in a value x. You notice I'm not expanding the denominator. Why? Because what if I have to plug an x in to find a value, aren't I? If I expand this, it would be 1 plus 2 cosine x plus cosine squared x on the bottom. How many times do I have to plug x in? Twice. How many do I have to plug it in here? Once. Let's leave it like this. So when you're using the quotient rule, please do not expand the bottom. Okay? So what are the problem types you'll get? Number 1, find the equation of the tangent line when x is pi over 4. We could do that.
Yeah.
Find where the slope of the tangent line is equal to 5. What would you do? You'd set the derivative equal to 5 and solve. Now that would be a nasty problem here. You could use your calculator and you could do it. Okay?
Yeah.
Those are the 2 kind of problems you're going to get for this section. Yes, ma'am.
So you would give us the equation, the original equation.
Yeah, of course. Yeah, of course. So the problem types aren't changing. Find the equation of the tangent line. Find where the slope is this. Those 2 problems are the same. I just gave you 6 more ways, 6 more functions and their derivatives. So now we can find even more tangent lines, which is really cool. Yes, sir.
How would you solve that?
You have a mighty solve button on that 89,
Oh, I got it.
right? Yeah. Or you could put it graphically, put 1 in y1 and 1 in y2 and see where they intersect. That's another way to do it. Yes, sir? Finding the equation of the tangent line? Sure. I would be glad to do that. I got a couple minutes.
23 looks like a real good.
22 looks good. Nice try, Hank. Hank is always thinking positively. I like that. Okay, find equations in the line that are tangent and normal to the graph of y equals secant x. Okay, I need to find an equation of the tangent line. What do I need? I need a point and a slope. Okay, so they told me x is pi over 4. How do I find the y that goes with it? Secant of pi over 4 is equal to 1 over the cosine of pi over 4, which is 1 over
Good morning,
2 over
BC.
2.
My name is Victoria Garcia, and I'm a Mexican American,
And
and
I am
each year,
going to-
Americans observe
Hi,
National
Victoria.
Hispanic Heritage Month